Hi, this is Larry Touchette. Today I'm going to give you a demonstration of ActiveCluster. This is our synchronous replication, transparent failover, active-active solution that allows you to achieve RPO0 and RTO0 between two data centers. Before we get started with the demonstration, I'd like to make sure you understand what ActiveCluster is doing and how we utilize two pure storage arrays in the same environment to provide active-active for your workloads. So if we just think about at the beginning how one host might connect to a single standalone flash array, what we have is a single host with two paths to a pure storage flash array. That host sees multiple LUNs that are configured on that array. It's going to see multiple copies of each of these LUNs because the host has multiple paths. That's okay. That's a normal thing in any environment that uses multipathing software. The host will see multiple paths to these LUNs. The reason the host is able to do that is because every copy of a LUN that the host sees is that copy of the LUN has the same volume serial number. So the way Pure Storage ActiveCluster works is we simply would add a second array to the environment. We would take this container that we call a pod that's represented by the dotted line there on the screen, and we stretch that between the two arrays. And when we do the stretch, that means we're going to initially copy all the data from the source array to the target array, create a full copy of data on that other array, and then we're going to transition into what we call synchronous I/O forwarding mode. Once we're in synchronous I/O forwarding mode, all this means is that every write that the host in this image sends to the array on the left is going to be synchronously forwarded to the other array, and we're going to wait for that array to acknowledge the write before we tell the host that the write is complete. So from the host perspective, the only thing that's changed here is that the host may have a little bit of additional write latency depending on how far apart the two arrays are in the environment. Now that we've got the arrays in sync and the data's in sync between the two arrays and we're acknowledging writes, we can simply just expose the LUNs from the other storage array to the same host, and then from the host perspective, really it just sees more paths to the LUN. And at this point, the host could do I/O on any of these paths, any of the four paths that you see in the array. And one of the big advantages of ActiveCluster and the way we've implemented it is that all of the LUNs, all the volumes are readable and writable on both sides of the ActiveCluster. So we literally do not care what array the host does its I/O through. Okay, Pure Storage ActiveCluster also allows us to do non-disruptive data migration of workloads between two pure storage arrays. So you might imagine, if you're kind of thinking ahead here, what we could do next. We've got a host, it's doing I/O through two flash arrays at the same time. It simply seeds more paths to the storage. So what we can do now is we can essentially disconnect the hosts from the first array. At this point, the arrays are still in sync and they're both maintaining a copy of the LUN. We can unstretch that pod or that dotted line container there from the old array on the left to the new array on the right, and now the host simply sees the paths to the array on the right, and we've effectively migrated all that data from one flash array to another non-disruptively by simply adding some paths to the host and then removing paths to the host. So from a host perspective, all it's going to see is that some paths come online and some paths go away, and the multipathing software in the host handles all of this seamlessly. Okay, we're going to jump into the demo now. So I want you to understand what the demo environment looks like and what you're going to see in the lab. It'll help you get a feel of how our environment's kind of set up. So what you can see on the screen here now is I've got two hosts. These are represented up here at the top, and two pure storage flash arrays that are in the environment. These hosts are running VMware, and there's a virtual machine running on the host on the left, and that virtual machine is accessing all of its data in a data store that right now is serviced and lives only on the array on the left-hand side, and that's the array that we call array 40, which you'll see in the demo. And so you want to think of the demo as kind of like site 4 and site 5. We've got a host called host 40, an array called array 40, and then likewise at the other site, we've got a host 5 and an array 5. So we'll keep a lookout for those numbers. Okay, you can kind of see here in the lab environment that we've got the array on the left, which is array 4. We've got the array on the right, which is array 5. You can see these are the dashboards of the pure storage arrays. Down here at the bottom, you can see the virtual machine that is generating some workload. We're just simply running iometer and generating some reads and writes to the array on the left. So you can see there that in the dashboard of the array on the left, we've got about 700 megabytes of reads and maybe about 200 or 300 megabytes of writes happening to just that array. So in order to set up ActiveCluster, it's quite simple. There's only a few steps. One of the first steps we have to do is connect the two flash arrays together so that they can do synchronous replication. And the first step to doing that is to going to one of the two arrays. I'm going to go over here to the array on the right-hand side and go down to the connection panel. And in the connection panel, I'm going to choose this option and get the connection key. And then I take that connection key. I'm going to just make a quick copy of it. So I copy the connection key, and then I go over to the array on the left, and I select Connect Arrays. So I'm going to paste the connection key there into the connection key box. And then up at the top, I'm going to add the management address, and I'm also going to select the synchronous replication type. I'm going to type in the IP address there of the other array and hit connect. And in just a few seconds, the arrays will be connected for synchronous replication, and we can see that reflected right there on the UI. Okay, now the next step in configuring ActiveCluster is to create a pod. So a pod is what I referred to earlier when we were looking at the screen, and there's that dotted line container that surrounds the volumes. We call that a pod. You can have multiple pods in the environment and put different volumes in different pods and stretch pods between arrays. So you can think of a pod as kind of a consistency group or a container that contains your volumes. One of the cool things that this lets you do is it means you don't have to synchronously replicate all of the contents of the flash array. You can have some workloads that exist only on one side or the other, and then you can have workloads that you put inside of pods, and you stretch those between the two arrays. So we're just going to go here to the array on the left and create a pod. Clicking on the plus sign there. I'll give the pod a name to make it awesome. We're just going to say pod 1. And then I've got a volume that was already existing. Now remember, I had a workload already running on the array on the left. So what you're going to kind of see here is the fact that you could take an array that is already running a workload, and it's configured in running that workload on just one flash array. You can install a second flash array into the environment and then non-disruptively configure ActiveCluster by stretching that volume inside a pod between two arrays. So we're going to do that right now. So I selected the volume and I chose move, and I'm going to choose a container for the volume, which is the pod that we just created, and click move. And all this is doing is simply a cosmetic move of saying that the volume should now be assigned as being a member of that pod. Okay, so now that we've got the volume inside of the pod, the next step is to stretch that pod to the other array. So I'm going to go to the storage tab here, select pods, select the pod that we just created, and then click on the add arrays button. And I'm going to add the other array to the pod. And that's going to automatically start the process of doing that initial copy of data from the array on the left to the array on the right. And you can see that here in the UI, that we see that the pod is online on array 4 and it's offline resyncing on array 5. If we go over here to the analysis replication tab, we can see in the view here that we can look at the asynchronous replication traffic that's represented by the blue line. And when the asynchronous transfer between the source array and the target array is done, we'll have the initial copy of data done to the array on the right, and we'll just smoothly transition into that synchronous I/O forwarding mode. So if we take another look at the pod right now, we can see that the pod is in a resynchronization mode on array 5, and it's in an online mode on array 4. So all of the workload that's happening for the pod right now would be happening only between host 4 and array 4 on the left-hand side. Okay, so now the initial synchronization of the data between the array on the left and the array on the right is complete. So we can see here in the UI that the pod shows that it's online on both array 4 and array 5. And the next thing we can do is take a look at the dashboard on the array, and we see that there's been a change in that we're no longer reporting normal writes for this workload, but we're reporting mirrored writes, which means that all of the writes that are happening to the array on the left are being mirrored and synchronously forwarded to the array on the right. So that's just a smooth transition from a workload that's not doing synchronous replication to a workload that is doing synchronous replication now between the two arrays. Okay, so next we're going to connect the host to the array on the right where we have the newly synchronized volume that's part of ActiveCluster. So I'm going to go into the Volumes tab and select to connect the hosts. I'm going to connect both host 4 and host 5 to the volume in pod 1, which is the pod that we just stretched between the two arrays in the ActiveCluster. Okay, now that the host is connected to the volume on both sides of the ActiveCluster, we can go into the vSphere web client and tell the host to rescan for storage. And this is going to cause the host to rescan and look for any new paths to the data stores. And in this case, the host is going to discover that it has additional paths to the data now. It has new paths through array 5 on the right-hand side, where previously we only had paths from host 4 to array 4 on the left. We're going to configure the multipathing for the host to round robin. And you can see here in the UI now that the host has multiple paths connected to the LUN. We previously had 4 paths connected through one storage array, and now we have 8 paths connected, 4 to each storage array. So if we take a look at the dashboards of each of the array, we can see some more changes happening. In this case, our reads have been split between the array on the left and the array on the right. And this is because we haven't told the host anything yet about how it should use the paths to the array. That means that the host is going to be equally doing writes to the array on the left and the array on the right. If you're in a configuration where the storage arrays are very close to each other and you're using ActiveCluster simply for high availability, like in a data center area or a campus area, you could potentially just leave the ActiveCluster configured the way it is, allow the host to do reads and writes to either side of the storage array. But in a case where there is a lot of distance between the arrays, we actually don't want the host doing any reads across the long distance link between the two sites, because that could impact performance. So the way we address that in ActiveCluster is by using this setting called the preferred array. All right, so the way we configure the preferred array for each host is by going into the host in the array. We'll go to the Details tab. We'll click on Add Preferred Arrays. That'll open up this dialog, and we want to say that host 4 prefers array 4, and then we want to go back to hosts and select host 5, and we'll say host 5 prefers array 5. So that completes the preferred array settings for the array on the left. Now, with ActiveCluster, you can move your workloads between either array in the environment. Non-disruptively and dynamically, you can move individual VMs between the arrays. So we're going to go to the other array at the other site and make those same preferred array settings as well, so that the hosts on the other site know where their preferred array is, and regardless of where you move the virtual machines, you'll get the best performance by having a virtual machine using only the local paths to the local array. So in the array on the right, the same thing. We're going to select host 4. We're going to add array 4 as the preferred array for host 4. Then we're going to go back out to hosts and select host 5 and go to preferred arrays, and we're going to select array 5 as the preferred array for host 5. So now that we've made this selection, if we go back to the dashboard of each of the two arrays, we can see that there's been a change in the way the workload is hitting the storage arrays. So you can see now that all of the reads have moved back to the array on the left side, and we're not doing any reads anymore to the array on the right side, but we still have mirrored writes happening between the two arrays, and all the mirrored writes are going across the replication interconnect that connects the two arrays together. Now that we've got ActiveCluster set up with the preferred arrays, I want to demonstrate how we can move virtual machines from one site to the other and maintain the best performance by using only the local paths at each site. So now that we have the preferred arrays set up, I can simply go into the vSphere web client And let's say I want to move this virtual machine from ESX host 4 to ESX host 5 at the other site. And when I perform this move, we're essentially going to see that the workload that was hitting ESX4, all of the reads that were going between host 4, ESX4, and array 4 are going to seamlessly move to the other site where the reads are going from host 5 down to array 5 on the right-hand side. So I'm just going to do a regular VMotion in the vSphere client. I'm not doing a storage VMotion, so we're not moving any data. We're just simply moving the virtual machine from one ESX host to another. And once that VMotion completes, we'll see that the reads have left array 4 here on the left, and the reads are now all happening at array 4 over there on the right. And you can do that at a per VM granularity. So you can have some virtual machines running in the same data store on the array on the left-hand side, and other virtual machines running again in the same data store on the array on the right-hand side, and they're all going to have that best local performance by using just the local paths to each array. Okay, so now we have the workload running on the host on the right-hand side, host 5. It's doing all of its reads to the array on the right-hand side, array 5. All of the writes are being synchronously replicated between the two arrays. And now we're going to get into some failure scenario testing with ActiveCluster. ActiveCluster uses a mediator to manage the failover between the two arrays in the environment. And this is necessary to make sure that we don't cause split brain. Split brain would be the case where you have two arrays that were connected for synchronous replication, and they're not connected, they're not in sync, and we want to make sure that we don't get into a situation where both arrays are serving a copy of the data to the hosts, but the arrays are not in sync. So this would be a very bad thing for the environment. One of the things that ActiveCluster does to prevent split brain happening in the environment is using a mediator in the cloud. We call this the Pure One Cloud Mediator. And the advantage of having a mediator in the cloud means that you don't have to deploy anything in a third site. The Pure One Cloud is automatically a third site that's in a separate failure domain from either of the sites where the ActiveCluster is located. And the way failover works is whenever the link between the two flash arrays is broken, the arrays will race to the mediator, and the first one to get to the mediator is able to keep its volumes online and keep servicing data to volumes that were in a stretch pod. And the array that is second to get to the mediator or doesn't get to the mediator at all, like in the case where an array were to fail, that array will stop I/O access to its volumes, and it'll make sure that the workload runs only on one side or the other, and you don't get into split brain. We have two arrays here in the environment. This is similar to the environment that we have in the lab right now. There's two hosts, one at each site. There's an array at each site, and we've got connections between from each host to each array. Now what you can see here is if the replication link were to fail between the two arrays, or if either one of the two arrays were to fail, both arrays will race to the mediator, and the first array to get to the mediator and claim that it's going to keep its volumes online is allowed to do so, and the other array has to block access to the volumes and prevent hosts from accessing it, or the array could simply be offline because you had an array failure there. So let's take a look at what that actually looks like in the lab if we simulate an array failure in the lab environment. Okay, so I'm going to simulate a complete array failure in the lab. I'm going to open up a command window here in the bottom right, and we're just going to issue a couple commands to take down the array on the right-hand side. Now this is going to be interesting, remember, because the array on the right is the array that is servicing all the reads for the workload, which is running on the host on the right-hand side. So we'll just start the process of shutting down one of the two controllers in the array. And you'll see that when we shut down a controller, we don't really have any performance degradation when we just lose one controller inside of a flash array. Okay, now I'm going to shut down the second controller in the array, and this is going to cause the array on the right to completely be unavailable from the host perspective. The host isn't going to be able to do I/O to this array anymore once this shutdown process completes. Once the array is completely shut down on the right-hand side, you'll see here that the UI on the array on the right-hand side is no longer available. If you take a look at the virtual machine down at the bottom, our workload has paused while the ActiveCluster negotiates a failover between the two arrays. And now here in just a few seconds, you can see that the workload has continued on the array on the left. So in this case now, the host workload was running on the right-hand side of the environment, and it was doing all of its work to the array on the right-hand side. And now we failed that array, and the workload has seamlessly failed over to utilize the array on the left for both its reads and writes. And you can see that here in the GUI, where we just see now that we have regular writes happening on the array on the left, and we don't see any mirrored writes. So we're not going to see any mirrored writes while the arrays are out of sync. We'll report regular writes when arrays are not in sync, and we'll report the purple mirrored writes when the arrays are in sync. Okay, so next I'm going to bring the array on the right, array 5, back online. And when the array comes back online, it's going to automatically reconnect to the array on the left, and it's going to automatically do an asynchronous replication to pull any new data that was written into the left array back over to the right array and seamlessly transition back into sync. So let's see that work. So I'm going to go here into the command line again and issue a command to start up one of the controllers in the flash array on the right-hand side. So if we keep an eye on the array here on the left, we can see that we're still just doing normal writes until we get back in sync. Okay, so the array on the right has finished starting up one of its controllers. We really only need one controller in the array to come back online, and then the two arrays will begin to negotiate and start the resynchronization. So if we go into the pods view on the left array and take a look at this pod now, we can see that the pod is still online on array 4. It's been online on array 4 through the entire demo here. And on array 5, it shows that it's resyncing. So the arrays have connected together, and we've started the process of doing an asynchronous copy of data from the array on the left to the array on the right. Now, all we have to do is a short asynchronous copy of any of the deltas, any new data that was written to the array on the left while we were out of sync. That's the only data that we have to ship between the two arrays to get back in sync once they are reconnected. And that all happens automatically and behind the scenes. And then once the array on the right has been fully in sync, if we go back now and look at the dashboard in the array, we can see that the purple mirrored writes has showed back up. The ActiveCluster is back in sync. Both of the pods are showing an online status. And we can see now that we're doing mirrored writes between the two arrays. And also, in addition, all of our read workload has automatically transitioned back from the array on the left over to the array on the right, which is the array that has the preferred host for that workload. So remember, in this demo, we started with the workload running on host 4 on the left. We did a VMotion of the workload to host 5 on the right. So host 5 is the preferred array for array 5. Once array 5 came back online and got back in sync, we put a signal on the storage network that tells the host that it's okay to use that array again, and the host will automatically start sending its read IOs to its preferred array, which is array 5 in this case. So we're all back to normal now with the workload running on host 5. We can see here in the dashboard on array 5 on the right that all our reads are occurring here, and all of our writes are occurring here as well, and those mirrored writes are additionally reflected in the other array. Okay, so that completes the demo of ActiveCluster. So what you saw there is how easy it is and simple to set up ActiveCluster. You simply have to connect the arrays, move your volumes into a pod, stretch that pod between the two storage arrays, and then you can see how ActiveCluster will automatically and seamlessly, transparently fail over workloads from one array to the other. And when we bring a storage array back online or recover an array from a failure, the arrays will automatically reconnect to each other, automatically resynchronize the data, and the workload automatically moves back to the site where you'd like it to be working. So thanks for watching.